Lesson 6. Algorithms and Flowcharts. Algorithms and flowcharts are two important tools used in computer science to represent and design processes, procedures, or problem-solving methods. Children will be able to learn what an algorithm is, the rules for creating an algorithm for a task problem, the advantages of an algorithm, what a flowchart is, symbols in a flowchart, creating a flowchart from an algorithm, the advantages or disadvantages of a flowchart. Neha: Hey Tia, do you know what an algorithm is? Tia: No Neha, what's that? Neha: Well, an algorithm is like a set of instructions to solve a problem or do something. It's like a recipe for making a cake or a map for finding your way. Tia: Oh, I get it. Like a step-by-step guide? Neha: Exactly. And you know what's cool? We can show these instructions in a flowchart. Tia: Flowchart? What's that? Neha: A flowchart is like a picture that shows the steps in the algorithm. It uses shapes and arrows to tell you what to do next. Tia: That sounds fun, Neha. Can you please explain the concept in detail? Neha: Sure, Tia. Let's begin to explore more. Problem solving. Problem solving is the process of identifying a problem, developing step-by-step instructions for the identified problem, and finally implementing it to get the desired output. Algorithms. An algorithm is a step-by-step instruction given to the computer to solve a particular problem. It is defined as a sequence of instructions that gives the desired results when executed. An algorithm provides a logical and structured way of solving a problem to the computer. The order of steps in an algorithm is important to get the desired results. Algorithms can be converted into high-level language programs that the computer can understand and execute to give us desired results. To solve any problem, you need to analyze and understand the problem and then find the best solution to solve it. Need for an algorithm. Writing an algorithm is considered the first step to solve any problem. Once the algorithm is ready, we can perform the task by following the step-by-step instructions. If the algorithm is correct, the task will be performed correctly. So, the purpose of using an algorithm is to increase the reliability, accuracy, and efficiency of getting the desired result. Advantages of an algorithm. 1. Algorithms are the stepwise representation of a solution to a given problem, which makes it easy to understand. 2. Algorithms are not dependent on any programming language, so it is easy to understand for anyone, even without having a programming knowledge. 3. An algorithm works by following a definite procedure made up of inputs. This helps in getting the desired result. 4. Each step in an algorithm has a logical sequence that makes it easy to debug. 5. By using an algorithm, the problem can be broken down into smaller pieces or steps. This makes it easier for a programmer to convert it into an actual problem. Tech Corner. A logical sequence includes a sequence of instructions that are designed to be executed one after the other. Characteristics of an algorithm. 1. The steps in an algorithm are accurately defined. 2. The results of each step are unique and only depend on the input and the result of the previous steps. 3. The algorithm always stops after a finite number of steps. 4. The algorithm receives some input and then gives the output. 5. The algorithm clearly states the input to be taken from the user, processing to be performed, and the output desired by the user. Creating an algorithm. Example 1. An algorithm to make a sandwich. Step 1. Get the description and details of the cooking recipe. What ingredients do you need to make a sandwich? Cheese, tomato, and bread. Step 2. Make the sandwich by grating the cheese, slicing the tomatoes, buttering bread slices, placing the tomatoes and cheese slices on the bread. Step 3. Follow the steps to make sandwich. Cut the tomatoes into fine slices. Grate the cheese. Toast 2 slices of bread. Put cheese on the bread evenly. Place the tomato slices on the bread. Keep the other bread slice on the top and the sandwich is ready. Step 4. Eat the sandwich. Example 2. Consider an example where you have to come back from school. Normally you would board the school bus and it will drop you home. Sometimes your mother would come to pick you up from school. An algorithm for coming back home by bus. Step 1. Wait for the bus in a queue. Step 2. Get on the bus. Step 3. Get down at your bus stop. Step 4. Walk down to your house. An algorithm for coming back home with your mother. Step 1. Wait for your mother at the school entrance. Step 2. When you see your mother entering the school gate, draw her attention. Step 3. Pick up your bag and walk out of the school gate with your mother. Step 4. Get into a taxi and tell him where you want to go. Step 5. Guide the taxi driver to your house. Tech Corner. Sometimes in an algorithm, we need to follow a different set of steps based on a condition or repeat certain steps till the condition is met. Example 3. An example of an algorithm for printing numbers from 1 to 20. Step 1. Store an initial value of 1 in X. Step 2. Increase the value of X by 1. Step 3. Print X. Step 4. If the value of X is less than 20, then repeat steps 2 and 3. Otherwise, go to steps 5. Step 5. Flowcharts. We can also show the steps of an algorithm in a graphical form. The graphical or pictorial form of an algorithm is called the flowchart. A flowchart provides a detailed picture of the flow of the steps in an algorithm. It uses special symbols to represent various statements of an algorithm. A flowchart is always drawn from top to bottom, showing the exact order of steps. It is often considered as a blueprint of the design used for solving a problem. While drawing a flowchart, we need to do the following. 1. Identify the input and output. 2. Identify the steps of the process. 3. Draw a flowchart using appropriate symbols. Flowchart symbols. In a flowchart, each operation is represented using specific geometrical symbols. These symbols are connected to each other by arrow lines to show the flow of a sequence of operations. The most common flowchart symbols are flowchart symbol, geometric shape, purpose. Ellipse. Start or end box. It is used to indicate the starting or ending point of the process. It is used at the beginning and end of the flowchart. Parallelogram. Input or output box. It represents the input and output of the process. Rectangle. Processing box. It represents the actual processing part of the flowchart, such as calculation. Diamond. Decision box. It is used to check the condition and compare two values. A diamond shape always contains a question. The next step in the sequence is based on the answer to the question, which is either yes or no. Arrows. Flow line. It is used to show the flow of logic from one process step to the next. Circle. Connector. It is used to show the continuation of a flowchart from one page to another. Rules for drawing a flowchart. Some of the rules to be followed while drawing a flowchart are given below. 1. The requirements for drawing a flowchart should be listed out in a logical order. 2. Every flowchart should have starting and ending points. They are represented by a start symbol and a stop symbol. 3. The decision box has only one entry point but two exit points. One exit point shows the true condition and the other shows the false condition. 4. The normal direction of flow in any flowchart is from top to bottom or left to right. 5. Only one flow line is used to connect the start and stop symbols. 6. If a flowchart occupies more than one page, then off-page connectors should be used to direct the flow of information. Fact Corner. One-page connector. The pairs of on-page connector are used to replace long lines on a flowchart page. Off-page connector. An off-page connector is used when the target is an another page. Advantages of a flowchart. 1. A flowchart supports better understanding by explaining the steps in the form of pictures. 2. It identifies the order of steps and makes it easy to implement as a computer program. 3. The flowchart acts as a guide or blueprint during the analysis and development phase of a computer program. 4. The flowchart helps to analyze a problem in a more effective way. Disadvantages of a flowchart. 1. Many a time, the program logic becomes too complex. In such a case, the flowchart looks long and difficult to understand. 2. When a program needs changes, its flowchart needs to be redrawn completely. 3. It is quite costly to produce and difficult to use and manage a programming language that enables the development of a program. Example 1. An algorithm and a flowchart to find the sum of two numbers. 1. Start. 2. Accept the value of first number and store in variable A. 3. Accept the value of second number and store in variable B. 4. Add the values in A and B and store the result in variable sum. 5. Display the value in sum. 6. Stop. Flowchart. Explanation. In this flowchart, start and end symbol shows where the problem-solving flow starts and ends. We need to draw a flowchart to add two given numbers. First, identify the given input. In this problem, inputs are the two numbers A and B. Accepting values of A and B are represented by parallelograms. The next step is to add the numbers, which is called processing in computer terms. The details of the processing is represented in a rectangle. The next step is to write the result of the addition, which is output in computer terms. This is also specified in a parallelogram. An arrow points from one step to the next step in the flowchart. The arrows show the flow of the problem-solving process. Creating decision-making flowchart. Example 1. Flowchart to find the profit or loss using the decision box or a given cost price and selling price. 1. Start. 2. Accept the value of cost price and store in CP. 3. Accept the value of selling price and store in SP. 4. Check whether SP is greater than CP. If yes, calculate profit as SP minus CP and then print it. 5. If not, calculate loss as CP minus SP and then print loss. 6. Stop. Explanation. In this flowchart, we have to find the profit or loss. The cost price and the selling price are inputs that are represented as parallelograms. In the next step, the selling price is compared to the cost price to find out which of these is higher. This will tell us whether there is a profit or loss. The answer to the question is selling price more than cost price. Could be either yes or no. This decision-making step is represented using a diamond symbol. If the answer is yes, it means that the selling price is more than the cost price and we need to calculate profit. If the answer is no, It means that the cost price is less than the selling price and it is a loss. Loss is calculated as cost price minus selling price. Repeating instructions in a flowchart. Sometimes we need to repeat instructions. For this purpose, we use loops. A loop is used to repeat instructions a number of times until the specified condition is met. While using a loop, a counter is required. A counter is a variable that is used to count the number of times a procedure is repeated. It can be named as x, counter, and so on. When the variable is declared, it is initialized to a value. The value gets incremented and decremented during the execution of the loop. Fact Corner. A variable is a name assigned to data. Its value keeps changing during the execution of a program. It is incremented and decremented as per the requirement. Representing loops in a flowchart. To represent a loop in a flowchart, if the condition is true, the flow line goes back to the decision box after executing instructions. The value of the variable used for checking the condition also needs to be changed so that the condition becomes false at some point. When the condition becomes false, the loop ends. Example 1. In this example, the even numbers are calculated between 9 and 100. Flowchart. 1. Start. 2. Initialize variable I is equal to 10. 3. Write I in standard output. 4. I is equal to I plus 2. 5. If I is not equal to 98, go to step 3. 6. Stop. Explanation. The repetition sequence starts with I is equal to 10. The condition I less than equal to 98 is checked. If the condition is true, the sequence is repeated and I is incremented by 2. The repetition sequence stops when the value of I becomes 98. A decision structure has been used to start and stop the repetition. Example 2. An algorithm and a flowchart to print the multiplication tab number. 1. Start. 2. Accept a number and store it in the n variable. 3. Store an initial value of 1 in the count variable. 4. Calculate n multiplied count and store it in multiple. 5. Display the value of multiple. 6. Check if the value of the count is 11. If yes, then go to Start. 7. If the value of count is greater than 10, then add 1 to count and go to step 4. 8. Stop. Explanation. In the above example, the repetition sequence starts with count is equal to 1. N is multiplied with 1 and the output is printed. Since the value of count is not equal to 11, count is incremented by 1. N is then multiplied with 2 and the output is printed. This sequence is repeated until the count reaches 11. A decision box is used for calculations. Flashback. Step-by-step instructions should be given to the computer to solve the problem. Problem solving is the process of identifying a problem, developing step-by-step instructions for the identified problem, and finally implementing it to get the desired results. An algorithm is a step-by-step instruction given to the computer to solve a problem or perform a task. An algorithm provides a logical and structured way of solving a problem to the computer. Algorithms can be converted into programs written in a high-level language that the computer can understand and execute to give us desired results. Each step in an algorithm has a logical sequence that makes it easy to debug. The graphical or pictorial form of an algorithm is called the flowchart. A flowchart provides a detailed picture of the flow of steps in an algorithm. It uses special symbols to represent various statements of an algorithm. A flowchart is always drawn from top to bottom, showing the exact order of steps. A loop is used to repeat instructions a number of times until the specified condition is met. To represent a loop in a flowchart, If the condition is true, the flow line goes back to the decision box after executing instructions.